Hello, I'm Mike McCulloch. Today I'd like to talk about special relativity and specifically time dilation in relativity. So you probably already know that if you're moving relative to an object according to special relativity, you will see that object moving more slowly or behaving as if it's moving more slowly. So if it's a clock, time will pass on that clock more slowly if you're moving relative to it. And also the object, if the object is looking back at you, it will see you moving slowly as well, which is very strange, but it has borne out in an experiment. So the equation looks like this. You have a dt prime on the left hand side, which represents the length of a time interval in the moving frame, and then you have a dt on the right hand side, which is the time interval in a static frame, so not non-moving. And then underneath that you have the denominator, which is root 1 minus v squared over c squared, and this is the correction. So the v here is your speed relative to the object you're looking at, and c is the speed of light. So you can see that the larger v is in this formula, the more dilated a time interval is going to be, that term on the left hand side, the larger that is, so the slower time will appear to move for the object you're looking at. So this is all very well and good, but Einstein did a thing here which is interesting, and it kind of works, but he allowed time to mold itself. He allowed an abstract concept of time that molds in order to make physical observations agree. And whereas that's all well and good, we have this abstract time, you can never actually determine whether that, there is no mechanism, is what I'm trying to say. There's no mechanism attached to it. There's just this abstract concept of time which molds itself to agree with the observations. But there's no mechanism associated with it, and therefore there's no way to test whether time is in fact dilating except by the observations that we use to infer that. There's no second opinion, if you like, and it's not very testable. So over the past few months I've been trying to derive the same thing in a much better way, using an analogy to computer games. So I play Minecraft quite a lot, and when you're in a multiplayer game, the computer that you're using has to calculate both your movements, and if you're playing with somebody else, it has to exchange information with their computer to find out where they are, and that takes time. And I had the thought that maybe time is a processing delay. So let's see if this works. So we have two bit like reference frames shown here, and one of them is moving relative to the other. These are actually grids in two computer games in a multiplayer game. So so if time is a processing delay, can we calculate that processing delay? Well, we can write down that the modified time, dt prime, is going to be d over s, where d is the amount of distance, in some sense, between the pixels in one game and the other one, and then s is going to be the speed at which the information is going to be exchanged. So for d, we will have, it'll be a Pythagorean addition. So we'll have the actual distance between the two pixels and the two reference frames, so we'll call that capital D. So we get d squared there. And then we'll also have a component as the two reference frames are moving relative to each other. So the diagonal distance will be v squared times, v times the time. So we'll get a d squared plus v squared dt prime squared, all rooted. That will give us the distance between the two pixels in the two games, and then we divide by the speed of light, so d over s. And then with a bit of rearranging, we get something that looks like this. So maybe you can see the similarity to relativity. It's a derivation which is subtly similar. There's this same Pythagorean diagonal in there, but now we have a mechanism for it. That is the difference here. So what you end up with, if you rearrange this formula, is the special time dilation formula for special relativity. It's exactly the same. But as I said, there's a huge difference in that there's now a mechanism to explain it. Time is a processing delay, and if the cosmos is something like a computer simulation. Now, I'm not necessarily saying that it is a computer simulation, just that it behaves like it. So this is so time is a processing delay, and this is more testable as well, because it's more testable because whereas in Einstein's formulation there was absolutely no chance of moving faster than the speed of light, in this formulation the limit at the speed of light becomes rather like the current Friedrichs Levy condition in fluid dynamics, in that it'll require a bit more processing, that's all, for the computer to load another pixel. So there is perhaps some loophole here towards a faster than light motion. Okay, so it may be that time is a processing delay, which is it's nice to attribute a mechanism for time. And yeah, so I hope you've enjoyed this short. I haven't published this yet, but I intend to soon, and I look forward to seeing you next time. Goodbye.